Okay, so we're going to continue with a video recording, and this is just a problem someone asked in Algebra Talk, and I got two other questions I wanted to ask, but they sent me an email, so I'm not going to identify that person. And so anyway, I thought they're good for everyone to see, and you'll probably have questions on them, so let's get started. So first thing we're going to do is we're going to take this simple equation over here, and I did an equation like this actually in class live, so if you go to that video and watch it, I actually go into more detail I'm going to go into here, and I did some previews of graphing lines and so forth, which I won't talk about here. It's going to solve the problem. So what you need to solve this problem is a good working knowledge of the distributive property. So whenever we have a number next to a parentheses, this means to distribute this number across the different terms, separated of course by addition and subtraction. So I'm going to distribute the 6 to the x to get 6x, and I'm going to distribute the 6 to the minus 7 to get 6 times 7 is 42, so 6 times a negative 7 is going to be a minus 42. And then we're going to go to the next one, and we have a minus 7 times an x, and that gives us a minus 7x. We have a minus 7 times a minus 6, which is going to be a positive 42. And this is going to equal x plus 6. And now this minus sign out here, we actually treat like a negative 1. So you can pretend when you see a minus sign next to a parentheses, it's really a negative 1. So we're going to go negative 1 times x gives us negative x. And we have negative 1 times negative 6 is positive 6, because 1 times 6 is 6, but they're both negative, so a negative times a negative is a positive, right? If you forgot, you could always check your calculator too, just to help verify. So I wrote that a little crooked, sorry about that. But we have 6x minus 42 plus 7x plus 42 is equal to x plus 6 minus x plus 6. Well, we can simplify a little bit here, right? Because we know that, first of all, we have a minus 42 and a plus 42. So a negative 42 and a positive 42 both add to 0, so they're going to cancel each other out. And we have a 6x and a 7x, right? So how many x's do we have left? If you start out with 6 x's and you remove 7 of them, you have minus 1 x's. You can think about if you had $6 in the bank and you go and spend 7, you have negative $1 left. But we're not going to write negative 1x, because usually when we only have 1x, we just write negative x. So on this side, we're just going to have negative x. That's nice, right? Now, what does this equal? Well, if we go to this side, we have an x and we have a negative x. So they're opposite signs, so x minus x is 0, or x plus negative x is 0. So these cancel, and I'm left with 6 plus 6 is 12. So we have a 12 over here. Okay? So I have negative x is equal to 12, and of course, I'll go through the last step, but that's going to imply that x is equal to negative 12. Okay, so how do we see that? Well, negative x is the same as negative 1 times x. So I'm going to write negative 1 times x. So instead of negative x, I'm going to write negative 1 times x is equal to 12. Then what I'm going to do is I'm going to divide both sides by negative 1. The reason I'm going to divide both sides by negative 1 is so I can cancel that 1 out. So I divide this side by negative 1, and these negative 1s are going to cancel and leave me with x. But if I divide the left side by negative 1, I have to divide the right side by negative 1. Oops. That's a 1, if you can believe it. Now these cancel out, and I'm left with 12 is x is equal to 12 divided by negative 1. The 12 divided by negative 1 is just negative 12. That's your answer. Okay, so I hope they answered the question that was asked. The main thing is, remember, distribute. You have to start up with a distributive property. 6 distributed to x gives me 6x. 6 distributed to negative 7 is negative 42. Negative 7 distributed to the x gives me negative 7. Negative 7 distributed to the negative 6. Negative 2 negatives give me a positive, so it's positive 42, and we have x plus 6. And you can treat this as a minus 1, so you distribute to the x, get negative x, distribute negative 1 to the negative 6. Negative 1 and negative 6 multiply to give me positive 6. Okay. Okay. So let's take a look at the next problem that was asked. I hope that clarifies any questions. Okay, so, well, let's do another one before that one. Okay, so let's come to this one. Now, this is one that someone asked, a good question. The whole idea with this question is to get rid of the fractions. So we have three denominators, and they're x, 5x, and 10, and our hope is just to get rid of them. We don't want to work with fractions. Once we get rid of the fractions, then of course it's like solving the last problem we did. So over here, I'm just going to start out by listing my denominators. Now, when you have x in the denominator, you have to remember you can't divide by 0, so you have to see what x cannot be. So what I'm going to do is I'm going to list my denominators, which are x. Oh, and I'll start by, since I have any whole numbers, I'll put a 1 under any whole number. Right? So I have x, I have 1, I have 5x, and I have 10. Okay? And what I'm going to do is I'm going to set each of these equal to 0 and solve for x. So I'm going to say x equals 0. And by setting the denominators equal to 0, I'm finding what x cannot be. Because if the denominators are 0, it means we're dividing by 0, which is not a possibility. I'm going to say 1 equals 0. That makes no sense, right? And that's exactly why we're going to be able to ignore it. But I'm just setting all the denominators equal to 0 just to give you a standard procedure. And 10 equals 0, which again makes no sense. Now, x equals 0. X is already solved for it, so that tells us x cannot equal 0. Right? Because by setting the denominators equal to 0 and solving for x, we find precisely what x cannot be for our final answer. 1 equals 0 doesn't tell us anything because 1 is never equal to 0, so I can just pretend that's not there. 5x equals 0, well, if we divide both sides by 5, we find out that x is equal to 0, which we already knew that x could not be 0. And 10 equals 0 is an impossibility. 10 can never be 0, so that tells us nothing. So our final answer cannot be 0. Okay, we had to check that beforehand. Generally in this class, when you're doing square root equations and when you're doing these types of equations with the x in the denominator, you have to go back and check your solutions or figure out beforehand what x cannot possibly be. Okay? So in this case, we know that the restriction is x cannot be 0. Now that we know x can't be 0, we can go ahead and solve the problem, and as long as we get something besides 0 for an answer, we're set. So the next thing we want to do is get rid of the fractions. So again, what I'll do is I'll just list the fractions. So we have an x. We have 1, 5x, and we have 10. Okay? So we want a number that is divisible by x, 1, 5x, and 10x. Okay? You could just multiply all these together and you would get 50x squared, but that's kind of a complicated number to work with. What you'll notice is that 10x divided by x is equal to 10, right? So that tells us that x divides 10x, right? 10x divided by 1 is equal to 10x. So of course, you don't have to check 1, it divides everything. Now we'll do 10x divided by 5x. Well, the x's cancel, and 10 divided by 5 is 2. So the x's cancel there, and 10 divided by 5 is 2. So we know that 5x divides 10x, and we know that 10x divided by 10, oops, the 10's cancel equals x. So we know that if we multiply both sides by 10x, we're so this tells us that each of my denominators divides 10x. So what I'm going to do is multiply both sides by 10x, and that's going to allow me to get rid of these denominators. So I'll multiply 10x over here, and I'll multiply 10x over here. Okay, now I'm going to use the distributive property and distribute the 10x to both my fractions. So I'm going to multiply 10x by the first fraction, which is 2 over x. And if you like, since I'm multiplying by fractions, you can put a 1 under the 10x. So that's going to give me 10x divided by 1 times 2 over x. Now I'm going to distribute to the second fraction. So it's going to be 10x times over 1. So it's going to be plus 10x divided by 1 times 3 over 1. And of course, we don't need the 1's there. It's just going to be 30x. Now I do the same thing on this side. And I'm going to, in this case, distribute the 10x to either term first. It doesn't matter. So that's going to give me 10x over 1 times 3 all over 5x plus, now I distribute to the other term, which is a 31 over 10. So I'm going to have plus 10x over 1 times 31 divided by 10. Okay, now I can go ahead and start canceling stuff out. So in this case, the x divides with the x, and 10 times 2 is 20, and 1 times, there's a 1 left over here. So this is just going to be 20. Nice, right? And 10x times 3 is going to be plus 30x. The 1's multiply on bottom to give me a 1. So it's 30x over 1, which is just 30x. Now this is going to be equal to, in this case, the x's are going to cancel, and 10 times 3 is 30. 30 divided by 5 is 6. So this is just going to be 6. Or you could cancel the 10 with the 5 to get 2, and then 2 times 3 is 6. Whatever you want to do it. And now here the 10's cancel, and this becomes 31x divided by 1, which is just 31x. Okay, now it's a problem like we had before, and what I'm going to do is I'm going to get all the x's to one side, so I'm going to subtract 30x from each side. And these, the reason I'm doing that is because if I subtract 30x from this side, 30x minus 30x is 0, so I get rid of all the x's on this side. So this is going to be 20 plus 0 is equal to 6, and 31x minus 30x is just 1x, or I can just write x plus x. Now the 0 doesn't matter, so I can just kind of forget about that. 20 plus 0 is just 20. And what I'm going to do now is I'm going to subtract 6 from each side. So I'm going to do minus 6 over here. I'm going to do minus 6 over here. Now, the reason I'm doing that is to get rid of the 6 on this side. But if I subtract 6 from this side, I have to subtract 6 from this side. So 6 minus 6 is 0. So I'm just going to have 0 plus x over here. And 20 minus 6 is 14. So I'm left with x is equal to 14 as my answer. And the nice thing about addition, you see when I multiplied both sides by 10x, I had to put parentheses around the entire side and multiply by 10x. Technically, when we subtract 6 from both sides, we use parentheses, but some of the nice properties we have for addition, we can just pretend the addition when we subtract or add from each side, we can pretend the parentheses aren't there. Okay, if you have questions about more, it has to do with order of operations, but it works out nicely. So if I add and subtract from both sides, I don't have to worry about the parentheses. But if I multiply or divide from both sides, I have to put the parentheses around all the terms on both sides before I multiply or divide on both sides. That's why we usually start out by adding or subtracting, and once we only have one term on a side, then we'll divide. So it usually makes things simpler when we can just start out by adding and subtracting, but in this case, it turns out better if we start by multiplying to get rid of the fractions. Okay, now I have one more problem that I'm going to do, and it's pretty much the same way as we did the last one. And what I'm going to do is, first of all, I'm going to start out by listing the denominators, okay? So the denominators I'm going to just write over here like I did before. And the first denominator is 9x plus 18. And again, I'm going to set it equal to 0, but because by setting it equal to 0 and solving for x, I find exactly what x cannot be, right? So, because that means if I solve for x here, if I set this equal to 0 and solve for x, that means if I plugged in that value of x into this expression, I'd have 5 divided by 0. So x cannot be that value. Okay, so it tells us what solutions x cannot be when I finish solving the problem. So what I'm going to do is I'm going to factor a 9 out to solve for 0, because 9 divides 9x and 18. So that becomes x plus 2 equals 0. Okay. Now you're saying, why didn't I just subtract 18 from both sides and divide by 9? And yeah, I could have done that, but the reason I'm doing that is by factoring the more complicated expression, I can see if it looks like either one of these expressions. And that's going to help me when I'm trying to find a number that's divisible by this term, and this term. So I factored the 9 out. Now if I divide, now notice that 9x plus 18 is equal to x plus 2 times 9. That's going to be helpful later on, because 9x plus 18 is divisible by 9x plus 18, x plus 2, and 9, right? Okay. So if I divide both sides by 9 now, I get the 9's cancel and I have x plus 2 is equal to 0. And that tells me x is equal to negative 2. Okay? So we know x cannot be equal to negative 2. Now the next denominator, that was the first denominator, right? We started out with this and we wound up with x cannot equal negative 2. The next denominator is x plus 2, and we set that equal to 0. And if that tells us x equals negative 2, but we already knew, so that means that if we set this denominator equal to 0 and solve for x equals negative 2, so that tells us we cannot let x be negative 2, because if we do that, we'll have 9 divided by 0. And we'll also have 5 divided by 0. but we already knew x could not be negative 2, so that doesn't tell us anything. And the last denominator is 9. If we set 9 equal to 0, that's impossible, so that doesn't tell us anything. Okay, so we know if we solve this equation and our final answer is x equals negative 2, and we did everything right, and we check our steps, that tells us that there's no answer to this equation. Okay. Alright, or at least in the case that negative 2 is the only solution, right? Negative 2 cannot be a solution. Other things can be solutions. Okay. So now what we need to do is we need to multiply both sides by an expression that is divisible by 9x plus 18, x plus 2 and 9, right? Well, we know that 9x plus 18 divided by 9x plus 18 is equal to 1, right? So it's divisible by the first denominator. We know that 9x plus 18 divided by x plus 2 is equal to 9 times x plus 2 divided by x plus 2, which is equal to 9. So 9x plus 18 is divisible by x plus 2. And we know that 9x plus 18 divided by 9 is equal to 9 times x plus 2 divided by 9. The 9's cancel to give us x plus 2. Right? So what we're going to do is we know that 9x plus 18, and when you see these types of expressions, the way your problems are generally going to work is the more complicated term is going to be, if you factor it, it's going to be usually a product or it's divisible by all the other terms. So what I'm going to do, I'm going to multiply both sides by 9x plus 18, but I'm going to write it as 9x plus 2. So I'm going to multiply this side over here by 9 times x plus 2. I kind of scrunch it in there. And I'm going to multiply this side times 9x plus 2. Sorry, I kind of scrunched that in there like that. And 9x plus 18 is equal to 9 times x plus 2. They're the same number. I just factored it. So this is going to cancel with this, and I just have 5. Works out nice, right? Now, so 9 times x plus 2, if I distribute that to this term, I get 9 divided by x plus 2 times 9 times x plus 2 all over 1, distributing to the first term, minus 4 over 9 times 9 times x plus 2 all over 1. So I just took 9 times x plus 2, and there's always a 1 on the bottom, and I multiplied it by 9 over x plus 2. So I have 9 over x plus 2 times this over this, minus, now I take 9 times x plus 2 over 1, which is this, and I multiply it by negative 4 over 9 to get this. Now things start to simplify nicely. The x plus 2 cancels with the x plus 2. I'm left with a 1 down here. 9 times 9 is 81. 1 times 1 is 1, and 81 divided by 1 is just 81. So I'm going to have 5 is equal to 81. Now, the 9 over here cancels with the 9, and I have 4 times x plus 2. So this is going to be equal to minus 4 times x plus 2. divided by the 9 so the 9 cancels with the 9, so I have a 1 down here. 1 times 1 is 1. So there's 4 times x plus 2 divided by 1, which is just 4 times x plus 2. Now, I can just use the distributive property. And I can distribute the 4 to the x, the negative 4 to the x if you like. And I get minus 4x. And I'll write the 81 over here. So it's 81 minus negative 4 times x is minus 4x. And negative 4 times 2 is minus 8. And we have this. Sounds good? Okay, we're almost done. You can probably see that. Well, we have 81 minus 8 is going to be 3. So we have 5 is equal to 3 minus 4x. And I can subtract 3 from each side. And 5 minus 3 is 2. 3 minus 3 is 0. And I have just bring down the minus 4x. Now what I'm going to do is I'm going to divide both sides by negative 4. And I don't have to worry about parentheses, of course, because there's only one term on each side. So I'll divide by negative 4 here, and I'll divide by negative 4. And dividing the right-hand side by negative 4, because this is negative 4 times x, this allows me to cancel. So my answer is 2 divided by negative 4 is my answer, but x is equal to 2 divided by negative 4. If I simplify, divide numerator and denominator by 2, this is give me 1 all over negative 2, which is equal, if you like, negative 1 all over 2, or which is equal to negative 1/2, however you want to write it. They're all the same. Doesn't matter if the negative is in the denominator and the numerator, or you can actually just stick it out in front, which means negative 1 times 1/2. Okay? So this is my value for x, and that's my solution. And since it's not equal to negative 2, I can accept this answer. Okay? So I hope that answers your question, and I look forward to hearing more questions from you. Thank you, and have a great day.